Hey, this is Ken Roosevelt. We're going to do another problem from the old Unit D chapter review problem set that's posted online. We're going to do problems number 21, 22, and 23. 21 is a radical equation, or an equation containing a radical, and 22 and 23 are problems solving radical inequalities, where it's basically the same problem, but that's an inequality instead. So even if I had just been given something with an inequality in it, I would have been forced to solve this first. So how do we solve this? Well, we want to isolate the part that is a radical by moving this 1 to the other side, makes it -1. And then you want to square both sides to undo the square root. So squaring the left side gets rid of the square root. Squaring the right side, you get a binomial squared, which comes out to this if you expand it. If you minus 3x over to the other side, you're going to get minus 5x. If you minus 1 over there, that's going to cancel out completely. And so you'll have 0 equals x squared minus 5x. You can factor out the x here, and using the zero product property, which says if something times something equals 0, then at least one of those somethings has to equal 0. So you set each factor equal to 0. Basically, the solution to any quadratic equation is the zeros of its factors. So one of your answers is 0, one of your answers is x equals 5. The question is, do both work? Because sometimes when you're solving radical equations, by squaring both sides you get false positives. So how can we check quickly which one works? Well, we can do it one of two ways. We can actually test the values, or we can draw a graph. And since we're about to solve inequalities in a moment, I'm going to draw the graph. I'm going to work off this one here, because this is the one I would put in my calculator if I was solving it by intersection of graphs method. I'd call this y1, I'd call this y2, and I'd look for where they intersect. This graph here begins at -1/3. And what does it do from there? It looks something like this. This one here is a linear equation, which starts at -1 and has a slope of 1. So maybe it looks like this. Now, I'm not perfectly to scale, but these two answers indicate to me that I'm looking, does this half parabola, sideways parabola, intersect this line in this place, or only one or the other, or both? And here, I think it's clear that it only happens at 5. It's going to happen there. There's no way they intersect at 0, right? And to test that, again, you can always plug in a point. 3, let me do it here. 3 times 0 plus 1 is 1. The square root of 1 is 1. 0 minus 1 is -1. You get 1 equal to -1. That's not true. This one does not work. Remember, squaring sometimes makes things that are opposite look equal. So if you had this as your original equation, both of these answers would work, but this wasn't your original equation. This was. So you got to make sure that when you squared things, you didn't introduce what's called an extraneous solution. And we did here. 0 is not a solution to this equation. All right, now, number 22, so the answer here is just 5. There we go. Now, number 22 asks a very similar question. It says, take this plus 1 and tell me where it is less than x. And there's a number of ways you can do this, but I'm going to work from the graph because the graph is easiest. I'm going to move this 1 over so that I have a simple linear equation on the right and a radical on the left. And this I'm going to call y1. This I'm going to call y2. And so basically I'm looking where y1 is below y2. Is y1, this is y1, is it below y2 here? No, it's above. Is it below out here? Yes, it is. So the answer is from 5 to infinity. Infinity is never included. Can I include 5? No, because 5 is where they are equal. So I can't include 5 either. Parentheses on both. Now let's do number 23. So 23 is still working with the same underlying equation. It's still a version of this equation, except they have modified it so it has an inequality. And which inequality does this one have? It has a greater than or equal to inequality. So again, I'm going to do the same thing. I'm going to move the 1 over to the other side. And since I've already solved the associated equation, and I have this graph, I know that 5 is the solution to where they're equal. The question is, where is this one greater than this one? And to know that, I either have to use test points or use the graph that I already have. I'm looking where y1 is the parabola, the curve. Where is y1? Above y2. And the answer is y1 is above y2 before 5. And the temptation would be to write, include 5, and say negative infinity to 5. So because a point before 5 works, if you did a test point, you would say everything before 5, right? No, not right. Because this part of the equation doesn't even begin until x is bigger than or equal to negative 1/3. That's the domain of this embedded function. So my answer cannot go all the way back to negative infinity. My first answer, is here. Is this point above here? Yes, it is. So I include that point, which is negative 1/3, up to 5. When you are doing, how do I want to say this? When you're solving radical inequalities, you have to think about the relevant feasible domain. You can't have answers like negative infinity, which are outside of the domain of possibility. It's negative infinity is way out there. It can't be a solution to this inequality because you can't even plug in points past negative 1/3. Let me give you an example. If you plugged in negative 1 here, you would get 3 times negative 1 is negative 3 plus 1, which would be negative 2. Can you take the square root of negative 2? No, you can't. So this would be an imaginary number, and this would be an imaginary number is greater than a real number. You can't even compare them. So you need to think about the relevant domain. And that goes if you're doing it on a number line too, right? Your number line would be not the whole number line. You can't have stuff way out there. Your number line would begin at negative 1/3, would have a solution at 5 that you would have to mark as a boundary, and your answer to any inequality would either be in this region or in that region, and you could solve it by test points. But isn't the graph so much easier? All right, there you go. That's it. I hope that helps. Bye.